How does a sliding mesh gearbox work? The sliding mesh gearbox is one of the earliest types of manual transmission systems, primarily used in older vehicles. It functions by manually sliding gears along the main shaft to engage with gears on the countershaft, thereby transmitting power from the engine to the wheels. The gearbox consists of three main shafts: the clutch shaft, which receives power from the engine; the countershaft, lay shaft, which has fixed gears driven by the clutch shaft; and the main shaft, which transmits power to the wheels. The sliding mechanism is entirely mechanical, requiring manual precision during gear changes. The clutch shaft is connected directly to the engine and transmits rotational power to the countershaft via a fixed gear. The countershaft carries a set of fixed gears that constantly mesh with free gears mounted on the main shaft. However, these free gears on the main shaft do not rotate with it unless they are manually engaged. The gears on the countershaft vary in size, and each corresponds to a gear ratio that determines the torque and speed delivered to the vehicle. When the gearbox is neutral, no gear on the main shaft is engaged with the countershaft gears, effectively disconnecting the power flow from the engine to the wheels. When engaged in first gear, the largest gear on the main shaft slides into the mesh with the smallest gear on the countershaft. This configuration provides maximum torque and minimum speed, making it ideal for starting from a standstill or driving on steep slopes. For the second gear, the driver slides another gear on the main shaft to interact with a smaller countershaft gear. This reduces torque, but increases speed compared to first gear. Similarly, the third gear, the gear on the main shaft, engages the countershaft gear, which provides a balance of speed and torque. Finally, for fourth gear, which is often direct drive, the clutch shaft and main shaft are locked together, completely bypassing the countershaft for maximum efficiency. The reverse gear in a sliding mesh gearbox is achieved by introducing an idle gear between the countershaft and the main shaft. This idle gear reverses the direction of rotation of the main shaft and enables the vehicle to move backwards. Advantages of sliding mesh gearbox. 1. Simplicity of design. The sliding mesh gearbox has a straightforward and robust design. It primarily consists of gears on the main shaft and countershaft, along with the clutch shaft and selector mechanisms. This simplicity reduces the number of components and makes the gearbox easy to manufacture and assemble. 2. Cost effectiveness. Due to its simple construction, the sliding mesh gearbox is relatively inexpensive to produce. It is economical for vehicles where cost reduction is a priority, such as in early models of commercial vehicles and tractors. 3. Easy of maintenance. The uncomplicated design of the gearbox makes it easy to service and maintain. Repairs, when needed, can be performed without requiring specialized tools or skills, making it ideal for use in rural or remote areas. 4. Durability. The gearbox is built with fewer moving parts compared to modern systems, which increases its durability and ability to withstand rough usage. This makes it suitable for vehicles operating in demanding conditions, such as off-road applications or heavy-duty vehicles. 5. High torque capability. The sliding mesh gearbox is capable of handling high torque loads, especially in the lower gears. This makes it effective for applications where power is more critical than speed, such as in trucks or agricultural machinery. Disadvantages of sliding mesh gearbox. 1. Difficulty in gear shifting. The biggest drawback of this gearbox is the effort required to shift gears. Since the gears need to be physically slid into mesh, the process demands significant force, especially if the speeds of the meshing gears are not synchronized. 2. Noisy operation. When gears are slid into mesh, the teeth may collide, causing noise and wear. This results in an unpleasant driving experience, with the gearbox being noisier compared to modern systems like constant mesh or synchromesh gearboxes. 3. Lack of smoothness. Shifting gears in a sliding mesh gearbox often leads to jerks and interruptions in power transmission. This lack of smoothness can make driving uncomfortable, particularly in stop-and-go traffic. 4. Requirement for skilled drivers. The effective operation of a sliding mesh gearbox requires skillful use of the clutch and accelerator to match the speed of the gears before meshing them. This can be challenging for inexperienced drivers and limits its widespread usability. 5. Inefficiency. The sliding motion of gears leads to energy losses due to friction and wear. Additionally, the gearbox lacks the precision and synchronization mechanisms of modern designs, reducing its overall efficiency.